final assignment on pedigrees, and it is a bit of a doozy, so take your time with it. It's only 3 questions, so you're probably thinking, oh, 3 questions, that's nothing. They're a little more, upper level thinking questions. These are what you would get if you're in a college genetics class. Prior to that, we were doing ones that you would see more in like a biology class, just a general biology class. So question number 1, I'll go through and do the first question with you, and then I'm going to leave you guys on your own to do questions 2 and 3. Now there's multiple parts to each question, so it will take us a little bit of time here. In the following human pedigrees, the field symbols represent affected individuals. You may assume that the disease allele is rare, and therefore individuals marrying into the family are unlikely to have a defective allele. So it's a rare allele. So let's take a look at that pedigree. What is the most likely mode of inheritance for this pedigree? So we're talking about, is it sex-linked or is it autosomal? Now looking at that, it's affecting both males and females pretty equally. So it's going to be autosomal. And then we have to determine whether it is dominant or recessive. These people have a lot of kids. So looking at that, or looking at any parents and their kids, it looks like you can have an affected parent and you can have kids who either are affected or are not affected by it. So let's say that this disorder is going to be a recessive disorder, even though it doesn't actually skip generations. We'll just put that in our minds for a second here. So that means that this lady would have at least 1 dominant allele, and this man would have to have 2 lowercase alleles. So let's see if that would work, if we're right or not. In order for them to have kids that have it, she would have to be heterozygous. So that means that this kid here would have 2 recessive ones. This one would have 1 capital 1, 1 lowercase 1. This one's recessive, this one's recessive. Heterozygous, and heterozygous. So that dominant allele is what's keeping those unfilled in shapes from being affected. That would mean that down here, so she has a capital letter, this one gets a capital letter and a recessive letter, capital and recessive. They have 2 kids who are affected with the disorder. So she would also have to be affected, which would give me something like that. They have a child who has it. So I'm going to say that this disorder is autosomal recessive because it is working out to where you could have that as your mode of inheritance. State the genotypes of individuals 1 through 5 in the following table using the letter A. I use the letter R's, but we could change it to A's. Use uppercase to represent the dominant allele and lowercase to represent the recessive allele. So person number 1, I have her genotype up here, and I'll change that to A's. It's heterozygous. Number 3. Number 4 is affected, so there are 2 littles. And number 5 is going to be heterozygous. So 1, 3, and 5 are all heterozygous. Number 4 is recessive. If individuals numbers 2 and 3 have another son, what are the chances that this son will be affected? Individuals, oh, I'm not done with that question yet. If individuals 2 and 3 have another son, what are the chances that he'll be affected? So here he is up here. Well, it is autosomal, so it doesn't matter as far as the sex goes here. We know that he's definitely going to be heterozygous because dad's going to give him that faulty R, and mom can give him either a dominant or a recessive. So he has a 50-50 shot. So I'm going to put 50% here. He may get it and he may not get it. Now, you guys who are doing these problems, you can either write it out on a piece of paper because I don't believe there's anything you have to draw in this assignment, or you could just type it in the text box and just number it as you go down. We're still on question number 1 here, letter B. What is the most likely mode for inheritance for this pedigree? So we got 3 girls who have it, 1 boy who has it. It's showing up in every generation here. And we have parents who are affected with it, but we have kids who are not affected. So if this was a recessive disorder and the parents had it, all of their kids would have it since they are themselves affected. So that is telling me that this disorder must be dominant because all you need is 1 allele to have it, not 2. And again, that is because I have 2 parents, both of them are affected. They have 3 kids, 2 of them don't have it. So that means that it cannot be recessive because they would have definitely had and displayed this trait. And it's going to be an autosomal disorder because it's affecting both males and females. State the genotypes of the individuals 6 and 8 in the following table using the letter B. 6 through 8, 6, 7, and 8. So because they definitely have it, I know that all these guys have at least 1 capital B. Now these ones down here do not have it, so they must be recessive. They have to have 2 recessive alleles. So person number 8 is going to be 2 littles. And in order for number 8 and this random girl here to not have it, the parents have to be heterozygous, and that gives them a 50-50 shot of giving you the dominant trait. So 6 and 7, they're both going to be heterozygous. This person down here, this girl, we don't know what her other letter would be. She could either have an inherited capital from dad and a capital from mom, or she got a capital from dad and a lowercase. So she's either homozygous dominant or heterozygous. But we don't know for sure because she does display the trait. If individuals 6 and 7 have another daughter, what are the chances that she'll be affected? So we have 1 daughter that doesn't have it. We have 1 daughter that does have it. So we could work up a Punnett square here real quick because we know that our parents are heterozygous. Being that they had kids that are not affected. Ooh, 25% chance that the daughter will not be affected, so chances that she will be affected, 75% chance, or she'll have a 3 and 4 chance of being affected. And those are just odds. Again, they could have like 15 kids, and this may be the only one who ever has it. It's the odds of things. It starts over every time you have a kid. So they always have a 75% chance of passing that on, and it's always a 25% chance of them not being affected. And in this particular case, we don't know if this disorder is good or bad, or if it has really any effect, it could be an earlobe trait for all we know. So that's it. Then you'll be moving on to question number 2 here. You're analyzing the following human pedigree. Assume that the individual marked with an asterisk does not carry any allele associated with the affected phenotype and no other mutation spontaneously occurs. Also assume complete penetrance. Use R or XRN for the allele associated with the dominant phenotype, R or X lowercase r for the allele associated with the recessive phenotype. So they're telling you right off the bat that this one is going to be sex-linked. So you have to decide if it's autosomal, sex-linked, dominant, or recessive here. And I'll give you a big hint here since they're telling you that, this X or XR, and it's all guys that are affected here, it's going to be X-linked for certain. And because the girls here do not have it, I would go with the recessive trait on that. So you'll give the genotypes, probabilities. You may need to work up a Punnett square to determine your probabilities of them being affected. And that question is not nearly as long as the first one we did. And then you got one more here. Following human pedigree shows a family affected by a specific disease. Assume that the individual is marked with an asterisk. Do not carry any allele associated with the affected phenotype, and no other mutation spontaneously occurs. Assume complete penetrance. State the most likely mode of inheritance. You got 2 people that have this disorder. Only 2. And there's 2 generations above it that don't have it, 2 generations below it that don't have it. That should give you a clear indication that this is going to be a recessive disorder here. And because we have 1 female and 1 male with it, that means it's affecting both sexes at the same time, so they're going to be an autosomal recessive trait. So that means you would have to have 2 lowercase alleles in order to inherit that trait. There are possibilities for genotypes, probability that an individual will be a carrier, so that means that they are heterozygous. So here you're looking for a heterozygous person, so somebody who is like this. What's the probability that individual 5 is going to look like that? And then this is your last part of question 3. The following human pedigree shows a family affected by a different disease. Assume the individual is marked with an asterisk. Do not carry any allele associated with the affected phenotype. So that is telling you that these people are going to be homozygous for it. You got a male and a female affected with it. Mostly males, but you do have that female in there as well. And you also have parents that do not have it, and yet you have a child that does have it. If you have a child that does have it, but the parent does not have it, that parent is probably going to be recessive. Yes, here we have it skipping generations again. These people had it, this one doesn't, these people have it. So I'd probably go with a recessive trait on that one as well. Individual 3 from the first pedigree has a second marriage, and individual 6 from the second pedigree with individual 6. They have a son and a daughter. What would the genotype of their son for the 2 diseased genes? What would the genotype of the daughter for the 2 diseased genes? So do the best that you can on that one. There's nothing, it ends at question number 3. Gave you a couple hints as you go through it. It's not worth a ton of points. Everybody should at least get page 1 right since I did it for you. Right there. And you can pause that video if you need to write down your answers. Alrighty, guys. I'll talk to you later.